Welcome to another series of Architects Talk with Kalebodur. And today we are in Turkey Build building fair in Istanbul. That is, I think, the 42nd. And we have a very special guest, Gijs van der Velden.
Thank you.
Welcome. You are special in many ways, actually, because you are not an architect, first of all.
That's true. I'm
And,
sorry for that.
And you are not coming from a technical area as well. You studied law for years, and then you have been working on design issues for a couple of many years, actually.
About
now
15.
you're running your own company, and you became a partner, and you are dealing with robotic design, which is a very contemporary issue, which has multiple meanings, actually. I mean, at least for somebody like me who has a distance to this area. But it is interesting that my son, who is studying in New York, is for the last couple of months working for a research project which is hosted by Prof Institute.
Mm-hmm.
And I think more or less he's doing something similar to what you do. So I have a brief idea about what's happening. And Mr. van der Velden actually had a conference here in this fair, which is titled Robotic Design, the End of Digital Design Cycle.
Yeah. So we think closing the digital design loop is something that becomes possible once you design digitally, manufacture digitally, record everything you do, and use that data to improve your process. And once you do that, you get a building process that's quite different from the one now, and a building process that can continue to improve over time, even without the help of us humans.
It's a radical transformation, not only including the construction process, but also the way we design, the way we think about bringing things together and organizing everything.
Yeah, and especially the last part is bringing everything together. I think one of the parts in building where there is a lot to gain is having all the different segments, all the different partners really operating as one machine. And that now becomes more and more possible using a BIM information model, but also all the digital techniques that are available, and the scanning, the information that you can collect.
I mean, going back to the starting point, I mean,
Yep.
you have studied law, and then I mean, you get an interest in design, and then I mean, everything started with, as far as I understand, at Joris Larman Lab.
Yeah, that's correct. So after my study, I couldn't find a job immediately, so I worked at Joris Larman Lab just to make his furniture. And gradually I saw how much fun it was to work in this kind of innovation, and he really taught me how these processes can be done. And fortunately, with my background, I was a very useful pawn in the whole process, connecting the designers, the makers, and more the budget issues together. And that's what I've been doing ever since. So I'm basically the realizator in the company to bring everything together to make sure that we have an innovation to show at a fair or at a new a gallery or a museum.
What is a robotic 3D printer?
Yeah, so one of the innovations we worked on at Joris Larman Lab was how can we 3D print much larger, and also in a way that would be repeatable over and over again. And slowly we found out that robotic 3D printing, robotic manufacturing would be the way forward for us, because we are making big furniture and small architecture pieces. So robotic 3D printing is nothing more than a robot that adds material on top of each other, so that you can create your 3D geometries without taking away material, but just adding material where you need it.
But there was still, I mean, lots of human effort included in the process, as far as I can see in the videos.
Yes, I mean, we never want to hide this. I mean, it's of course an innovation process. We probably work with 4 people and 1 robot. The robot standing still most of the time because the software still needs to be written, and we simply don't know what's going to happen. So we try it, we look at it, we see what's happening, and we improve the process. In the beginning, that's very manual, and by now our process is completely digital. So we have cameras on there, we have sensors on there, and we basically don't have to do anything anymore, and it's 3D printing our geometries for us.
When I was a student, I mean, the computer age was just starting in the way that we have this first generation of PCs and first generation of AutoCAD or something like that, and everybody was thinking that I mean, one day, I mean, it will be possible to push a button and obtain a design at the end, like it goes something like this. But later on, I mean, we started to understand design is something else and production is something else. So, I mean, what is the feedback on design, all these developments in the technology? What do you think about it?
Yeah, well, I think you're right. They are separate, and especially the aesthetic part of the design is never going to be done by a robot, of course, or by a software. But we see this whole process becoming more and more integrated because we make the design based on the material research, based on the data we collect. When we have the bridge out there, we measure how strong it is, how it's behaving, and that data we feed back into the design rules, and the design rules take this into account and automatically adapt when they are designing the new bridge. So the more connected all these different elements in the building process are, the less you can take them apart and give them to separate people to do. So we also see much more integration of the different professions coming closer. And that's also what happens in our company. We have architects, we have engineers, lawyers, and makers all working on this one robotic process. So it's becoming more central to the process, and then you have different people working on that.
When I was watching actually the videos that you delivered, what I thought was something like this. I mean, in the traditional method of construction, either a furniture bridge or a kind of a, let's say, house, building, whatever it is, there are lots of materials involved altogether. So it is a kind of a plurality or richness of a kind of a material accumulation. You use brick, concrete, steel, and things like that. But when you go to the robotic production, at least at the moment, I mean, they always prefer to carve one single material. Either it is steel or some composed material, whatever it is. I mean, is it on the other hand a process which is limiting innovation and design?
Yes, for now. We have started metal and we discovered it's actually quite a complex process, and there's so much to learn before you really understand how to build with this. But you have to imagine that bricklaying or woodworking is a skill that has been practiced for many thousands of years, and with the robotic manufacturing, we now have 5 years under our belt. So
just the beginning.
It's just the beginning,
Yeah.
and what is interesting is that all these robots they talk the same language. So once all these individual skills are learned, it will become a task to integrate them, but because they all speak the same language, this is not going to be very difficult. And you see that any of these developments are quite exponential in growth. So in 2011, when we started, there was maybe 10 projects around the world. Now there's thousands of projects around the world, and you see the development shooting quicker and quicker all the time.
When we talk about digital design or digital studio, I mean, in my faculty, for example, it always recalls, I mean, a kind of a free form expression. And it is like different than Cartesian geometry, and it is like everything is waving in the sky and things are going. Why is it like that? Because I have seen your bridge as well.
Yeah.
It was something like that. I always see that it's a kind of a expressionist manner to underline that it is a different process.
Yeah. It's a really interesting process to see, because once you start designing digitally and you optimize a building, or you have a computer program optimize a building, the outcome is actually quite different than what we had the last 2,000 years. It's organic. We have done several projects where we imitate the way bones grow or the way trees take up forces, and that's a very efficient use of material. And efficient use of material is something that fits really well with the additive manufacturing, because all the material you use for your building, you actually have to lay down, and it takes a lot of time. So the less material you use, the quicker you're done, and that's efficient again. So on 2 points, creating these topologically optimized shapes is just more efficient and therefore smarter.
And what I see, actually, looking at your work, is art and architecture and construction are blurring onto each other.
Yeah.
Because I mean there are quite similarity between what you labeled as art and what you labeled as functional object, either a bridge or something like furniture, for example. And you have produced lots of material for MoMA, Victoria Albert Museum, maybe Centre Pompidou. Am I right? Mm-hmm. So how do you see the relation between this blurring into each other, the art and architecture?
Yeah, I think for us, there's the relationship is that these have been classic separated professions. But they have something to share, and that's what's happening in the Joris Laarman lab, is that these come together, and you see there's very interesting outcomes there, because art has something to teach an architect or an engineer, and vice versa. So once you combine those, the outcome is inevitably going to be new and therefore interesting to see. And for us, it was also using art in these more technical engineering projects is really important to communicate to people what you can do to create a sort of a wow factor. Because if you do an engineering approach to such a new technology, people might not even notice because they have seen it before. And we wanted to show, okay, once you have a technology like this, maybe you can make this. It's maybe not what everybody's going to do in the future with this technology, but I think that's just one of the figuring out where it could go is important to get people enthusiastic and to get people curious about the direction.
So you are not actually picturing an abstract, futuristic position, but rather, it is something open to lots of contributions and transformations.
It is
throughout the process.
Yeah. I mean, of course, the aesthetics is really Joris Laarman's, and he has developed a certain design language for himself. But once this technology becomes available, and that's what we do at MX3D, we create a software technology for other architects, for other engineers to work with. I mean, we're really curious to see what they're going to make with it, because in principle, it's just a tool like a saw or any other tool that we had before. But one of the objectives of this project is to show as many different sides of this new technology, and that's what we've been doing with the bridge. So not necessarily showing what the future is going to be, but what it could be.
What is the budget-wise comparison?
Yeah, now it's way too expensive compared to a normal bridge, of course, but that's mainly because there is a lot of man hours in there to do the development. But you have to imagine that at a certain point, a robot, he can work 24/7. Maybe we stop for a second.
It was interesting, the announcement.
The robot,
Interesting.
Yeah, so cost-wise, I think at the moment we're definitely not competitive yet. But we see that for complex structures where there's a lot of welding involved and where there's a lot of manual work needed, it is already creeping closer together. So once the technology like this becomes fully automated, you can spin it 24/7 and you have several of these machines working on a single piece. It can actually increase the lead time and be cost efficient. In Holland, for example, we have almost no welding people left. It's a skill that's slowly dying out. And even if it would be the similar cost, people are very interested in this because the robot is always there and he will continue to work, and once he learns a skill, he's never going to lose it again. And that's an interesting aspect of this kind of manufacturing as well.
Yeah, and in one of your sites you say our main philosophy is we speak robot.
Yep.
What's it?
Yeah, we speak robot. We wanted to show people that for us, a robot is a machine that we control completely, and we know how to make it do something that they might want it to do. Because when they come to our site and they see, oh, they're printing a bridge like so and so, they might wonder whether we could also have the robot run around and do another action, and yes, we can. So that's we speak robots.
And how do you see the future of construction industry? I mean, is it just a side research? I mean, innovative, but I mean, which always stay there, but or I mean, it will become a mainstream manufacturing tool.
Well, I think there's for different materials there's different answers. So for metal, we don't see a huge introduction into the construction world because, I mean, if you look around in this hole, it's quite hard to see how a relatively slow process could deliver a big building like this. But what we do think is that all the process steps, the digital process steps that we have now researched in our technology are going to be mainstream in building industry. So having a fully closed digital design loop is going to be normal. So designing digitally, manufacturing digitally, maybe with prefab structures, but still it's all digital, it's all controlled, it's scanned, it's logged, it's checked by sensors, so that the next construction can be done even more efficient. Concrete 3D printing might have a bigger introduction in the industry, but still, if you want to build skyscrapers, it's probably going to be more efficient to do prefab. So the 3D printing is going to be used for very specific buildings, maybe a Zaha Hadid kind of exterior wall, but not for 95 or 99% of the buildings. So it's a niche market, but the digital design process behind it, that's definitely going to be mainstream.
If you compare architecture with other design areas, I mean cars, furniture, etc., architecture is bound to a significant place, a location, a topography, I mean, ground, on the ground. Once you build it, you cannot move it, you cannot turn it, and you cannot carry it. So it is, I mean, contextual. It stays somewhere with reference to sun, I mean, the wind and the view, but more important than, it has a cultural context, it has a historical context, and it has a, I don't know, maybe social, political, whatever it is. So it is within a continuity with a certain area. On the other hand, all these technologies are tending to simulate architecture as if it is something like furniture design, car design, which can be manufactured independent from the context. So, I mean, is it something radically changing the meaning in architecture?
Yeah, it's interesting that you see that. I actually see it exactly the opposite. When I look around in this neighborhood, I see a lot of architecture which is prefab, which has
That's true,
no
yes.
relevance to the location.
That's true.
And I think by introducing this kind of digital manufacturing, you can make adaptations to the specific location without extra cost. Now it doesn't happen because organization-wise, everybody's like, oh, having a drawing here and this concrete wall, oh, that's going to be complicated. But with this digital design and manufacturing, you can have decoration. You can adapt to the position to the sun better, so that at one point it's less isolated and other more isolated. So I actually think that this is going to help architecture find his cause, and that is designing for that specific place, for that specific culture.
Thank you very much. I mean, we had a general idea about what is happening. I'm sure, I mean, everybody can visit your website and can get more information. Then the company name is MX3D.
That's right, multi-axis 3D printing.
Yeah, and is there any room for young Turkish architecture students and architects?
There is always room. Unfortunately, the visa is sometimes a bit complex, but we're always open, and we're looking a lot for people that have interesting design skills or have been trained to work with robots. So they're definitely keen to apply. But we're also an international company, so if you have a project here in Istanbul, we're more than happy to work together. So we have our software is going to be soon available, and then we're going to send it out. And if you have a robot here, you could make a project like we did in Holland, just the same. And so that's one of the possibilities as well.
Thank you very much for being with us.
You're welcome. Thanks, was good.